Okay, so not all the molecules follow the octet rule, where there are a total of 8 electrons around the atom. In this video, we will go over the examples of the exceptions to octet rule, and specifically talking about odd electron species, incomplete octet, and expanded octet. So first, odd electron species. These molecules are exactly what their name refers to. These molecules have odd number of total electrons that make you unable to complete octet rule. These molecules with odd numbers of electrons are called free radicals or simply radicals. Although it does not complete the 8 electrons on valence shell, these molecules still exist because of the lack of ability of Lewis structure to completely visualize the free radicals. Only few of these free radicals exist because they are very unstable and reactive that they form bond with other molecules to become stabilized. For example, a free radical NO2 reacts with H2O to form HNO3 and NO. Examples of free radicals that often come up on homeworks or tests are ClO2, NO, and NO2. The second exception to octet rule is incomplete octet. These molecules have even numbers of electrons, yet are unable to complete the octet rule due to its characteristics. So the most obvious and familiar example is H2. Because hydrogen can only have maximum number of 2 electrons, it cannot form uh, it cannot complete the octet rule. The other atoms that form incomplete octet are boron, beryllium, and aluminum. You're able to observe that these atoms only form 2 or 3 bonds without additional electron pairs. This is due to their characteristics of being in group 2 and 3, and due to their low number of electrons. Uh, this characteristics of incomplete octet are almost always not possible with other atoms other than beryllium, boron, and aluminum. So you should definitely memorize these B, BE, and AL and H for incomplete octet. These molecules are able to complete its octet rule by reacting with other molecules. For example, boron trifluoride can react with ammonia to form F3B and H3, which gets rid of the incomplete octet and complete the 4 bonds and octet for boron. The last and probably the most confusing one is expanded octet. There's one important rule which allow atoms to form expanded octet. So the atom or element needs to be in the third row or beyond. So why third row? This is because due to the nature of electron configuration, or how the electrons in each shell are placed in an atom. So if you study electron configuration, beginning in third energy level or third row, the atoms are able to access d orbital. So for example, first electron shell has one s2 and therefore 2 valence electrons to be filled up. The example of this is hydrogen and helium. Second electron shell can have 2s2 and 2p6, total of 8 electrons. This includes variety of atoms such as oxygen, nitrogen, carbon, etc. And finally, third electron shell can have 3s2, 3p6, and 3d10, a total of 18 electrons. So it is unlikely for all the electrons to fill up 18 spots on the valence shell, but we have to notice here that it can break octet rule and form expanded octet. So when should you expand your octet and have more than 8 electrons on one atom? Consider expanding it when atom is in third row or beyond, and has formal charge, and has formal charge, has non-zero formal charge or weird one. For example, H2SO4 has a formal charge of +2 on sulfur and -1 on oxygen. Since sulfur is in third row, we can expand this valence shell and get the get this Lewis structure. Sulfur now forms 6 bonds, total of 12 electrons on the shell, and have formal charge of 0 for both oxygen and sulfur. Therefore, the right structure is more stable and more likely to happen in the real world than the left one, although it does not adhere to octet rule. So typical element that has expanded octet is phosphorus, sulfur, arsenic, selenium, and xenon. So these bolded phosphorus, sulfur, and xenon are the most typical ones seen in homeworks and tests. These 5 examples are not the only ones that can form expanded octet, by the way. Phosphorus and sulfur can form many expanded octet molecules such as uh, PCl5, PO4 3 minus, SF6, SO4 2 minus, etc. Consider expanding octet for these atoms if you happen to get weird non-zero formal charges for uh, your atoms and its bonding atoms. The one that may surprise you right now is xenon, because xenon is a noble gas, and you probably know that noble gases don't react. So although xenon is noble gas known to be stable, it can still form bond with other molecules and have expanded octet. This is because some xenon isotopes are reactive while others are not, and there are also more reasons further behind this. Uh, but I'll say that for now. So xenon form reaction generally with halogens to form structures such as xenon F4 and XeCl2. You're able to observe that xenon forms expanded octet of more than 8 electrons. This one has 1, 2, 3, 4, 5, 6, 12 electrons, and this one has 10 electrons around this shell. These are the so odd electron species, incomplete octet, and expanded octet are the 3 examples of exceptions to the octet rule. Yes, it adds much more confusion to the Lewis structure and octet rule, but it is still important concept to know in chemistry. So yeah, the lecture is now over. Thank you.